Hello everyone. Thanks for joining this session. So today will be about GraphQL as a data layer for your application. And actually quite funny, yesterday I tweeted about being at this conference and people asked me where the beach is. So I hope you already went to the beach. I didn't, so maybe that's a good plan for later this afternoon. My name is Roy. I'm from Amsterdam in Netherlands, Europe. And it's great to be here, also to visit some of my co-workers who I've only been able to see online for the past 2 years. So I hope for all of you it's also a place to see some co-workers again. So before we'll be diving into GraphQL, I'll be telling a bit about why you might need it and why you might need a data layer for your application or maybe applications. So maybe if you're in a small company, this is what your setup will look like. You'll have an API that's connected to a database, maybe to some third-party services, and you would have one client, maybe two. So this is all fine, and here you probably don't need an API layer. You have one API for your service, which is all good. But you can imagine if you start adding new features, and you maybe have one small team, maybe you have separate teams, people will need to update their code bases. So you might need to update your API, you might need to update your client because you're making changes, you're adding new features. So both probably need to change the code. You will have more code in your client or less code in your backend. Both things need to be updated, and both things can be separate teams. It can be the same team. It can be individuals. It can also be third parties, because maybe you buy your backend at some other company that created it for you. But what if you don't have an active backend team? So suppose you want to make changes to your backend, someone else makes changes to your backend, or maybe this backend is a legacy system. This is something I see a lot as well. People have a front end that they iterate on, and then they have a backend that actually isn't being actively maintained. So maybe you need to make changes on the front end, and maybe you also have similar or multiple clients using the same backend at the same time. So if you're making changes to all these different systems, you need to keep track of where you want to make these changes. So how to solve this? For this, I will be telling you about GraphQL in this talk. But first, a little bit about myself. As I told you, my name is Roy. You can find me on Twitter with the handle @GetHackTeam. I do a lot of different stuff. Most of my time I spent working at StepSen, which is a GraphQL as a service company. And we have a booth, so make sure to meet me or Sam up there to get a demo about the things we're doing. I also write books about GraphQL, React, TypeScript, a lot of cool technologies that I like. If you haven't write a book yourself, I mean, you don't have to, but it's a great way to learn new technologies. For me, it's also a way to put your knowledge in perspective. You think you know a lot about something, and then you start writing a book, explain it to other people, and then suddenly you don't. So also, if you want to speak at conferences, it's also a great way to extend your own knowledge. I would highly recommend it to all of you. So let's have another look at a typical setup you might have at a company. As I told you before, this could be a small company. You just have one client, one backend that's maybe talking with a database, maybe with different services. Or more often, you have multiple services, multiple APIs, multiple clients. And then you hope your architect or whoever is responsible for this in your team, your department, or your company, depending on the size, is making it as structured as this. But I think if we're honest, most of the times it will look like this. You have things going everywhere, clients talking with each other, clients talking with different APIs, with different backends, and maybe even different databases connected to different backends. So there's multiple things going on in your company, and often it's hard to keep track of what's happening where, especially if your company gets bigger, if you're working with multiple departments. Setups in architecture can get messy quite soon. And also, how do we like BFFs? Is someone using a BFF at their team? Like a backend for front end? So one person is. Well, maybe more persons are without actually knowing, because maybe you have an API in your team that is specifically made for your client, but you don't know it's actually a backend for front end. I mean, you don't necessarily have to call it that way. So why does the setup get complex that we already saw? So we have multiple APIs, multiple clients, and data coming from everywhere and data going everywhere. So it gets complex because teams update code. And this can be a team in your own department, it can be a team that's maybe sitting right next door at your office if you go there, or it could be a team that you have day-to-day relationships with. Or maybe it's a team that you never speak with because they are in a different department, they are maybe at an even completely different company. And if these teams update code, it is very straightforward when you have it like this, because you have one API, you have one client, you will know if your API doesn't work anymore in your client, probably someone updated code somewhere. But if you cannot update your own backend, maybe because it's a different team or a different company building it, it will get more complex, because where you're going to do this business logic? If someone changes the API you're using in your client, what will you be doing? You probably start adding more code changes in your clients to make sure that you actually have all the changes you need. So where does business logic go? As soon as you start growing or start interacting with multiple clients or multiple APIs. I often see companies using their client to put business logic. Is someone doing this at their current company? You don't have to tell me, because more people are doing this than actually they should be doing. But maybe you're putting business logic here, because you have an API, you cannot change the API because, well, maybe it's not your own API. So you're going to start making the changes in your client. But maybe you also created a BFF, you created a data layer, an abstraction layer, normalization layer, however you like to call it. Maybe you're putting this logic there because you want to make changes to whatever's happening in your API because your client needs this data in a different format, or maybe it needs data from different APIs. And you maybe even have multiple clients using the same backend. So sometimes you can see these clients using their own BFF. Maybe they have one BFF that's being used by separate clients. But if you make a change in your backend, you sometimes even need to change both clients, because one client is using one API endpoint route that might be changing, while the other one is using that endpoint route as well, but it's taking different fields of data from that endpoint. So each could maybe get their own BFF, because as soon as you get this split, you've got different clients doing different stuff. So I've seen this at a company I worked with. We had a mobile application that started out to be somewhat a clone of the web application. And at some point you start iterating, and maybe your web application is moving faster than your mobile application. Or maybe you actually figured out that the users of your mobile applications are different users than the one using your web application. So at this point your initial API might not be sufficient anymore. So you start making changes, but you don't want to make these changes in both clients. So each could get their own BFF, or maybe you start decoupling backends, because one client is using backend A, while a different client is using backend B. And as soon as you start with a setup like this, I think you're actually going to start needing a data layer, because this data layer can take care of normalization, different as it will be for backend for frontend, because it will be one data layer that can handle both clients, or maybe all 3, all 4, or 5 clients you're working with. And more importantly, we can use GraphQL for this, because GraphQL is perfect if you want to use the same data or the same API endpoint in different ways. So first, what do we already know about GraphQL? Are there any GraphQL people in the room? I see one, that's great. 2. Do I get a third one? No? Well, I can always try. So what do you already know about GraphQL? Let me give you a quick overview. So GraphQL is a query language for APIs. I think I spoke with some people already yesterday that asked me about graph databases. I think it's a very common idea to think a graph database is linked to GraphQL. Well, I think the biggest thing they have in common is the word graph, because besides that, there necessarily happen to be much things the same. I can see GraphQL APIs going for REST APIs, for databases, either relational or NoSQL, but also for graph databases. And I think one of the, like Fauna is a popular example of a graph database. They have GraphQL built in. For Neo4j, I see a lot of people using GraphQL. So it is well, it's easy to use a graph database with GraphQL, but you're not limited to it. And it's a query language, meaning it also isn't a framework. It's another misconception people sometimes have, like GraphQL is a framework on its own. It's mostly a query language or an API protocol, or whatever you like to call it. If you cut it down to the bones, it is actually a specification on how you could use APIs with GraphQL. You're not limited even to the spec, but most frameworks or clients or server-side tools you use to build GraphQL APIs are compliant to the spec, because that's what you have a spec for after all. So it's a query language, and it looks like this. So this is an example of a GraphQL playground. So if you work with GraphQL APIs, they have a schema in which you can find all the types that are in there. And I will tell you more about the type system later. But this schema is often exposed through a playground or an IDE. And there are different IDEs for it. And the cool thing here again is the spec doesn't tell you which IDE to use, but it will give you some guidelines if you want to build an IDE your own. So on the left side, you can see a query, which is a, well, it's a query like you have a query in SQL, but it's just formatted a bit different. So it's declarative, as you would expect from a SQL as well. You'll be asking for data, and the data will be returned in a similar format that you ask it in. So the left side is a query. You can send a query in a document. So if you interact with a GraphQL server, you typically send a document to it containing your query, containing some variables you might have. Maybe also send over some headers, because most GraphQL APIs operate over HTTP. So if you already are familiar with REST or maybe with SOAP, you can interact with HTTP in the same way. There are some slight differences, which well, you can find online or you can ask me after this talk. So I won't go into detail about that now. And on the right side, you can see the response. So the response will always be in a JSON format. So you can see we have JSON, we have a field called data, which contains all the information that we requested. And you can see we have GitHub user, which is the name of the query, the operation. You can see the fields bio and followers returned, which are also the fields we request on the left side. And something else we have with GraphQL, it is not only a query language, it also offers a single endpoint for multiple resources. So if you already work with REST, you maybe have 10 different endpoints, or maybe you have 40, or maybe you have even more. And typically with a REST API endpoint, one endpoint is doing one thing for you. And probably it will get data from one database table only, or maybe from one other REST API. Typically it doesn't combine data. So if you have a database that is a relational one, and you have information about orders and customers in there, typically you have an endpoint to get your customer data, and you have another endpoint to get your order data. Sometimes you combine it, but often it's different endpoints. With GraphQL, everything is in one single endpoint. So this is an example of a Twitter API. So Twitter doesn't have a GraphQL API itself, but this is a GraphQLized version. And in here you can see we're getting information about tweets. So we're doing a search on Twitter for all the tweets containing the query Einstein, which is a keyword. And then you can see we get the tweets, but we also get the author of the tweet. And if you go to the Twitter REST API, to get the author of a tweet, you actually need a second REST API endpoint. So you can't get all this information in one single endpoint. You need to call different endpoints at once. In GraphQL, you typically get all this information in one single endpoint. And this can be nested information, as you can see here, but you can even flatten it depending on what GraphQL framework you're using or how you're actually normalizing the data you will get from this REST API endpoints. And then something else, which I already told you about, is the type system. So GraphQL depends on the type system, meaning that everything you do in GraphQL should be compliant to the type system you have in there, which is based on your schema. So when you create a GraphQL server, you typically have to create a schema as well. And in the schema you can find all the data you have, but also the types of that data. So you can find if it's a string or a number or a Boolean, but you can also find the types of relationships. So if you go back to the tweet example, you have a type definition for tweet, which contains maybe something like a content, and then it also contains the author. The author will be a relationship, meaning it has a type on its own. And through IDEs or GraphQL Playground, you can often introspect your schema. And the schema can also be introspected from the API directly by sending an introspection query, which is just an operation to get information about the GraphQL API. But most IDEs or GraphQL Playgrounds will also let you introspect this yourself using a GUI. And in here you can see we have a type called date for the field created at, a type called string. We have a type called ID, which is a built-in scalar. So in GraphQL we have custom scalars, but also built-in scalars. And built-in ones are ID, string, we have integer there, Boolean. So these are built in, meaning that every GraphQL API can use them. And then also you can create your own types, which can be relationships, but it can also be something completely different. And because every field has a type definition, you also know in your application or when you're sending a query what you can expect in terms of data. And then something else, GraphQL is often seen as a replacement for REST. And I think I'm also someone to blame for it because I'm not really a fan of REST APIs in general. But GraphQL can easily coexist with REST APIs. So if you're using GraphQL, you're not limited to GraphQL. You often also see companies using both. So they either create a GraphQL API and then map GraphQL queries to a REST API endpoint, or they do it the other way around. They have REST APIs and then they create a GraphQL API on top of it. So they can easily coexist. So this is a meme I once made. I'm not sure if people are into memes, but as a developer you can be married to REST while still use GraphQL on the side, which I wouldn't recommend maybe in terms of relationships, but in terms of technology it's fine to use both side by side. So if we go back to our data layer, which is the talk of today, maybe you're not familiar with the term data layer. So if we ask the internet, a data access layer or a DAL is a computer program providing simplified access to persistent storage or data. So it can be a database, it can be a different REST API, it can be another GraphQL API, it can also be just a file or a document you have on your computer somewhere that you want to expose. So this data layer is something we'll be using to reuse data inside different clients and also to use some of the data that we have in our different backends or APIs and bring them all together so you can query them across different clients. So you may be thinking at this point as well, I already built an API, so my API already is a data layer, which is correct because your API is probably a data layer for your database or for your third-party services. But typically most APIs aren't usable by different clients at once without getting some of the complexity that we saw before. You make changes in your backend and then you need to make changes in your front ends, which typically you don't want to do, or maybe you even need to make changes across different integration layers. So we're creating a data layer based on a data layer because this normalization layer, this big abstraction layer that we'll be building with GraphQL, will be querying all the different APIs that you have underneath. So creating a data layer can be done on different ways. You don't even have to use GraphQL for it. Maybe you're using an API gateway and you're mapping existing API endpoints you have in this API gateway, so you can bring them together for all your different clients. But we can be using GraphQL for this as well. So you can see a data layer here. It will be connected to different backends. Now it's just backend A and B. But for most companies it will probably be backend A to Z or maybe even more. And these backends will be mapped in this data layer, and then this data layer can be used by all your different clients using GraphQL. And this means you can scale to an unlimited amount of clients and backends, because the backends can be created on the right side of your data layer, while the clients can access these backends through your GraphQL data layer. And the nice thing about GraphQL is that you, as a user or as a client, you have complete control over the data that you receive. And if you want to make changes to this GraphQL data layer, you don't need to make changes to all the different backends or to all the different clients, because you can just add new types or new graphs to your schema. Because every backend in this setup is a graph. So if we go back to the model of graph databases, if you work with a graph database, you probably know that graphs are easy to combine, they're easy to construct, and they're often also independent of other graphs. So for GraphQL it's the same. If you create graphs for your different backends, you can have a graph for your backend A, maybe that has customer data, and maybe you have backend B, which is order data, maybe you have backend C, which is some type of ORM containing order data, maybe it's a CRM or a CMS, it doesn't really matter, because all these things will be connected in your data layer that works independent of all the different layers, but all the graphs are in there. So with GraphQL, you can also combine schemas. So if we look at our graph setup here, we can have a backend A, backend B, backend C, D, whatever you want, and then combine these different graphs using GraphQL as well. So you don't need to combine an API gateway where you need to map endpoints or responses to each other. Instead, you're just creating a combination of different graphs inside your GraphQL schema. And this way you combine this data from different services without having to directly connect these services to each other, which is something you don't really want to do. You don't want to connect different services directly to each other. You typically want to create a layer that does this for you. Because that way you can easily swap out any of these services in case you start migrating, in case you start adding new services. Maybe you want your database to change, but it doesn't mean you want your API to change as well. And as I said before, you can unlimitedly scale this, of course, to the limitation of your team, because one team cannot take control of 10 different backends, but maybe 10 different teams can. So GraphQL shouldn't be the bottleneck here. And also, you don't want to update every backend to work well with GraphQL. So at StepSen, we created something to declaratively create a GraphQL API for all your different backends, in case you don't have a GraphQL backend already. And you can easily do this using the CLI, and I will show you different ways to do it later on as well. So if you actually would want to get started with a GraphQL API, you can use your existing data source already and use this CLI-based setup to import existing data sources. So what we would do, we would take the schema, which is if you have a MySQL or Postgres database, we can just find the schema of your database and convert it to GraphQL. If you have REST API endpoints, we can take a curl request, take the response, map it together with your headers and your post body and create a GraphQL schema for you. Or you can also do it yourself by just using GraphQL schema design language, which is another great thing of GraphQL. There is a specification telling you how to construct a GraphQL schema, how to set up things. And then in this setup, you can also create directives. So GraphQL has some built-in directives, which you can see with the add. So add REST is a custom directive we've built at StepSen. There are some built-in with GraphQL. But if you look here, you can see how extendable it is. So if you would want to create your own custom directive, you could already start doing it today. So maybe you want to create your own GraphQL software that works with other GraphQL APIs. You could add custom directives and make it work like this. So this is just the start of things you could do with StepSen, because we're going to have another look at combining schemas. As I told you before, everything in your backend can become a graph, and we can combine these different graphs into one GraphQL API. And this can be done in multiple ways, and how you do this actually also depends on your team, on your department, or your company. Because the first way to bring together GraphQL schemas is called schema stitching. And as the words say, you're bringing together multiple schemas. And this was introduced as the first way to bring together GraphQL schemas, well, quite soon after GraphQL was released. So GraphQL was released in 2015 as an open source library. Before, it was already being used internally by Facebook, and there's a nice documentary about it as well, released at GraphQL Europe conference a couple of years ago. So at Facebook around 2012, they had one big issue. Their social medium became more popular. So people were using their social medium every day. But the bandwidth of the data plans wasn't as big as it is today. So today, most people probably have unlimited data plans. But if you go back 10 years, people didn't have unlimited data plans. And they maybe even didn't have 3G. So they're working with 2G or maybe even lower internet connection speeds. So Facebook came up with, or actually a small team at Facebook came up with a protocol or a specification to get only the data that you need. And then at one point they also figured out that to get the data they need, they will need to connect different services together. So schema stitching was one of the first ways to bring together different schemas. And it actually requires you to write and deploy code to stitch schemas. So you can imagine if you have two GraphQL APIs at your company, you need to create a third GraphQL API, which is the stitching layer that connects with the underlying GraphQL APIs that you want to use, which is perfectly fine if your entire organization wants to work with GraphQL. And a GraphQL server typically consists of at least two things, sometimes three. So if you write your own GraphQL server, you typically need a schema, which is of course where the type system relies on. And then you also need resolvers. So these are your controllers or your connectors, however you like to call them. These are just functions or models to get data from your database, from a REST API, or wherever you like to get your data from. And then there's a third thing in here, which is called context, which you can see as a overarching function that controls, that actually has data used by all your different resolvers. So if you do authentication, there are multiple ways to do it. You can do authentication in resolvers, but also in context, meaning you don't need to reuse or duplicate that logic. But this is what a GraphQL server looks like. And if you want to work with schema stitching, you would need to write a GraphQL server that stitches other GraphQL servers. So as you can imagine, it's a lot of code you need to write. So if we look at this example, you can see you have two different backends. You have backend A and backend B. You would need to create a GraphQL server for backend A or backend B, so for both. And then your data layer, your GraphQL API, will be a stitching layer that takes the GraphQL APIs you have for backend A and backend B. And these can, of course, be written in different frameworks. So maybe you've written your backend A in Java with GraphQL, and then have backend B in Go with GraphQL. And for both programming languages, there are great frameworks out there to build your own GraphQL server. And then in your data layer, you write resolvers, which are the connectors to get data from the underlying servers to get this data up. But then you've got an important decision to make, because if your company is using different programming languages for different backend services, you actually need to make a tough decision about what programming language you want the stitch layer to be in. Because if you choose for schema stitching, you need to write this layer yourself. And if you have one team that's working with Java while another team is working with Go, it could be a tough decision to go with Go or either Java for the GraphQL layer, because if one team is changing something in their backend, they also want to make this change to the schema stitching layer. So typically I see companies that go for schema stitching. They either have one programming language at their company that's being applied on all different backend services, or they choose to go for one team that controls and maintains the schema stitching layer. Meaning you actually create another team at your company that is responsible for bringing together all the different data sources that you have. So you need to make a decision between either technology A or technology B, and maybe you even have a third or a fourth backend programming language in your company. That will make it very tough to make a decision what programming language you'll be using for this stitching layer. And as I mentioned before, it's really important to make a good decision here, because otherwise one team that makes a change in the service cannot change it for all the other services at once. So what does schema stitching look like? So this is an example with JavaScript, but you can basically do this for all different programming languages. You will need to write code to stitch schemas. And at the top here you can see different schemas being pulled in. So we have a local schema, which maybe is a normalization that you want to do with your data layer. We have a product subschema, which might be coming from a different GraphQL API. It might be coming from some software that you bought externally. And then we have a CMS. This can be a headless CMS. It can be a CMS that you're running on your own services. It can also be a CMS from an integration partner. You need to define them. You can extend them. And then you need to write resolvers to bring data together. So in here you can see an example where I'm taking data from the CMS and adding the CMS data to my product schema. So you can imagine I have a service that has product information, and then maybe I have a marketing or content team that is working in a CMS, and I want them to enrich the product's data. And with schema stitching, you will need to write all this code to bring together these different services. Which again is fine if you have a team that wants to do this, or if you're using the same programming language across all the different backend teams. And then there's another approach called federation. So schema stitching was working well for a lot of companies, but they came to the conclusion that the configuration and writing and deploying of all the code maybe wasn't the best solution for all companies out there. So federation is a different approach that takes a bit less code, and you need to write and deploy a schema that you can federate. So you still need to have different GraphQL APIs, and then you can write one schema called a supergraph to bring together all these different schemas. So a supergraph is a graph consisting of different subgraphs or subschemas. There are different ways in there. There are also different ways to name these things, which is something that's actually changing now. So GraphQL has been part of the GraphQL Foundation since 2019. So as I mentioned, it was developed at Facebook, open sourced in 2015. And then since 2019, there is a GraphQL Foundation, which is part of the Linux Foundation, meaning that the technology is no longer dependent on Facebook or Meta, wherever you like to call the company, but now it's being part of a large open source community that's also supported by different companies that are a member of the GraphQL Foundation. So at StepSam we also became a member of the GraphQL Foundation quite recently. And in there are different working groups working together on the specification, working together on the same specification for different services and tools. And in there we also work on a specification for federation. So what is called a supergraph today might be called different tomorrow, but the concepts will remain the same. But at least for all of you, it's nice to know that there will be a shared specification for this federation approach later on as well. And this supergraph typically only consists of a schema. So everything you do to federate different sub-schemas is write a GraphQL schema that will make sure to delegate the information from all the underlying schemas in one supergraph. And these requests will be mapped to underlying services. So you can imagine this supergraph should be aware of all the underlying sub-schemas, and it should be aware about how to get the data from these different schemas as well. So this is what it looks like. So this is an example with Apollo Federation. On the left you can see a super graph. You can see their interfaces defined there. So maybe you're familiar with languages, a programming language that use a type system. In GraphQL you also have interfaces, you have types, you can extend both. So you can create a type that's based on an interface, and then you can even extend that type to have different fields as well. It's typically what a type system looks like. And then on the right you can see an implementation of a type that is combining different schemas. You can here see a join is there, so it will be joining user information and post information. So these can be different services. Maybe one is coming from a CMS or a CRM, maybe the other is coming from a custom service you've built. And then in here you need to bring all this data together. And as you can see, it's still the same GraphQL schema we saw before, the same notations, and it's heavily dependent on custom directives. And these custom directives are a way to extend the options you have in a GraphQL schema. And you can make joins either on type level, as you can see like this. So my type post is joining data from different schemas, or you can do it on field level as well. So maybe you're bringing in fields that you want to join based on a different graph. And it has one catch though. To make a schema like this with all the different custom directives, all underlying subschemas should be working with Apollo Federation, because otherwise there would be no way for the Apollo Federation layer that you built to be aware of the information in the underlying schemas. So if you're working like this, you maybe have one team working in Java, and I don't believe Apollo has a Java library, but they do have Kotlin, which is quite similar. And then there's ways to create a Go Apollo server as well. So if everything in your backends is built in Apollo, you can easily use Apollo Federation and bring together all this data in one data layer. It still needs to be configured and deployed, so they don't have a managed service. And it heavily depends on your team, of course, to make sure that you deploy this Docker or this code, however you like to containerize it, to one of your clouds. And writing this gateway is quite similar to writing a schema stitching gateway. You still need to define the subgraphs or the subschemas, however you like to call them, and where they live on. So they can be living on an endpoint, they can be living somewhere locally inside your servers. And then you need to create a new server that will expose the schema. So we cut away the logic of resolvers, because resolvers are being done by the custom directives. But you still have a setup to configure the different subschemas, and then also need to create a server that you will deploy somewhere. So that might feel overwhelming. At least the very first time I was looking at different ways to bring together data, everything felt really overwhelming. But luckily there's a different example as well. So if we go back to what we do at StepSam, you can federate GraphQL declaratively, meaning that you still need to configure where your data comes from, but you no longer need to create resolvers, or you no longer need to have custom directives that are dependent on the underlying subschemas. So what you can do is import the schema of every backend, even if they don't support GraphQL, which is a nice feature. We saw before that federation with Apollo only works if the underlying services are also using Apollo. And with schema stitching, we saw that it only works if all the underlying services are built in GraphQL. So we've took these two constraints of existing solutions And also made a solution that works if all your backends are GraphQL, but even if one of your backends is a REST API. So maybe you're working with REST APIs or even SOAP APIs or databases that don't have an API. With StepSign you can combine all this data in one GraphQL schema without having to convert all the underlying services to GraphQL on their own. And again, you can do this using the CLI. We don't have a GUI to do this for you yet. We might do it in the future. But what I really like about the CLI first approach is that it's very native to developers. So you like to work with your terminal or your command line or whatever you like to call it on your device, and just use a CLI to do whatever you like to do. And it also makes it very easy to automate these tasks. So if you want to import data sources every time they change, you can just use the CLI and program it any way you like, maybe in a shell script. And of course, you can also write GraphQL schema design language because we chose to follow the GraphQL setup and just use the specification GraphQL already has. And again, we're using custom directives here to extend what GraphQL can already do for you. So if you would already have created a GraphQL schema for your GraphQL server, you can also just throw away your resolvers, reuse the type definitions you already wrote, and then use custom directives instead of resolvers to get the data for you. And then you can merge schemas using just GraphQL SDL without having to need schemas, without having to need subschemas that either rely on Apollo or already are relying on GraphQL. And for this, you can use more custom directives because custom directives really is the way to extend a GraphQL schema. And the GraphQL type system also lets you extend types. So you can have an interface, and then you can create a type based on an interface by using implements, and then types can also be extended. So the type system here is really helping you to make combinations of different types of data. And also you would be creating, maybe you're creating a schema for one of your services, then you can create a third schema or a second schema that's just extending data from the underlying schemas. So if you want to automate stuff, it is a nice way to regenerate the schemas of every service and then bringing them together by just extending types. Or you can also create a sequence of queries from different microservices. So maybe you need to get data from one service first. So what I typically see at companies, they have an authentication service that will let you get a token, but this token should be used to get information from all the other services you might have. So using a custom directive called sequence, which we created, you can actually take different steps to collect data from different sources and then bring them together and have one response type for this sequence. And these backends I told you about, so backend A, B, or maybe backend A to Z, they can also be microservices. So everything I showed you today can easily be swapped out by microservices because GraphQL is also great for microservices in the same way as it is great for different backends. So every microservice can be a graph on its own. You can combine them, you can make different combinations. Microservices are of course, or maybe not of course, because I've saw companies having microservices that look more like a monolith, but microservices should be domain specific, meaning that every domain can have their graph that you can then bring together using GraphQL. And something I really like about GraphQL, it makes your backends more composable long term. Meaning that if you want to swap out the service later on, you can just create a new graph or you can connect the graph to the new service. Your GraphQL schema doesn't really have to change. The only thing that changes is the way you get the data from the underlying services. And GraphQL has built-in custom directives. One is called deprecated, that helps you create versionless APIs. So one thing I typically hate about REST APIs is that people create different versions, and then the question is when should you create a new version and how do you keep track of the versioning? And what will happen if one of your clients is relying on version 2, well maybe a different client is relying on version 2.1 and then you release a version 3. Should you update all underlying clients? Should you keep maintaining version 2 or version 2.1? With GraphQL typically your APIs are versionless, meaning you have one schema that you expose. In this schema you can use custom directives to annotate if something is being deprecated in the future, and then the clients consuming it can already make the changes accordingly and be aware of changes that happen in the future. And it's easier to be backwards compatible as well because you can just create a new type and support that and deprecate an entire type. And something else I like here as well, if we go back to the microservices example, I often see companies going monolith first. So you create a new project, you create a monolith. Later on, you probably discover that it's easier to have different microservices because maybe some things don't scale as you expected, or maybe you're having different nodes running the same monolith, which can lead to concurrency issues. With GraphQL, you can also swap out graphs to be working for a microservice, while they first maybe worked for one part of your monolith. And also they let you innovate short term, because every change you want to make in your client no longer relies on your backend making changes accordingly. Instead, you can create a GraphQL query to get your data. You can change field styles, so you can add extra fields, remove fields. You can even use the built-in custom directives of GraphQL there again to make data conditionally. So there are tons of things you can do in the short run while not converting your entire company to GraphQL just yet. So that was it. I hope you have some questions for me as well. As I told you before, we have a booth at which we would love to give you a demo in case you want to know more about what we do with StepSen or want to know what GraphQL could do for your company. So thanks for your time, and then we have enough time to answer questions now. Yes?
From a security standpoint, if I'm putting all of the ability to query whatever you want onto a client, how do I, with GraphQL, restrict maybe fields that they're allowed to see based off of that client's access level? Is there an idiom for that?
Well, it depends. So it depends what framework or library you're using to create your GraphQL API. But typically what you would be doing is either on field or type level, restrict access. You can say this field or this type can only be accessed if you have a valid token or if you're part of this group or that group. So it really depends on the framework you're using.
What happens on the front end? Is it just silently fail if they ask for C, or does it error out?
It also depends. So on GraphQL, all data is optional by default. You can make data required by using an exclamation mark. But what you can do there is if you don't use an exclamation mark, it will just return null. And then yeah, so if you build your own GraphQL API, you can do all these things in the context. But you can also do them on resolver level or even with annotations in your schema. It really depends on what you're using. Yes?
Things like this could be pretty useful from a convenience standpoint, streamlining certain aspects of what we're trying to do. So some more curious about the performance implications of it. You kind of alluded to it has some benefits because Facebook chose this approach, and it seemed like they used less data as a result of it. Is there a data, savings that's across the board, or does that have to be approached a certain way to accomplish it? And is there any other sorts of performance benefits in terms of speed or anything like that, or does it depend on the project itself?
That's a good question.
A traditional SQL approach, something like that, say.
Yeah. So about GraphQL performance, it really, so if we look at the setup we saw today, you have different backends. One constraint could be if one of your backends is slow, then the thing in its whole will be slow as well, same as you would have in an API gateway. So there are plenty of things you can do with this approach with caching, make sure things run in parallel. But also if you look at the bandwidth, quite recently I was working on a post and some videos about load testing with GraphQL. And suppose you have a GraphQL endpoint and you're just asking two types of data, like two fields. And maybe someone is asking that field like 10,000 times in a couple of seconds. You can already see the change in data. So maybe instead of 30 megabytes of data going on, you only have 3 megabytes because people are using less fields. So it really depends on how you set it up. There's a lot of things you can do with caching depending on the library you use. There's something called persistent queries, meaning that you can say this query to get information maybe from my homepage or information about a user. If you know things don't change that often, you can persist the query and just return the data that you want. So there's tons of performance optimizations you can do. So the reason Facebook created this was because they wanted to use the same API endpoints to get all the data you need. If you have an overview of products, you maybe want to show only 2 or 3 fields of data on your front end homepage. Well, if you go to the detail page, you maybe have 20 different fields. So with REST, you need separate endpoints. With GraphQL, you have just one endpoint and you change the fields you request. And especially with those setups, you can see the difference. So if you don't create a separate endpoint to return less data and REST, then you're just getting way too much data, and in the end it will pile up and affect your performance as well.
I have one follow-up question about the graph.
Yes.
Say you have a database full of clients and you're trying to group them based on the criteria that they meet. Is there a way to, other than just straight up caching each result, because it could be in very, very many different kinds of queries that you perform, is there a way that you can say only re-query this if this item has changed, since the last query has ran? Or is that not possible?
Well, in theory, like I said, everything is possible because you can write your own GraphQL server, you have resolvers, you can apply any sort of logic there that you want. If you create a normalization layer or data layer using like a schema approach, like either federation or what we do with StepSend, it will be a bit different. Depending on your database, you might be able to work, or the REST API that you have underneath with e-tags, see if something has changed. You should probably be pulling data if you have a created at or updated at timestamp in your database. You can use that and just see if it has changed, do something or not. But it will depend because you need to keep track of the transaction before to know if it actually has been updated since the last time you got your data. But in theory, everything is configurable, so it really depends on how you would create it as a developer. Thank you. Okay. Yes?
What is the performance implication as you approach petabytes of data in your GraphQL environment?
So if you create an extra layer on top of existing services, you mean?
No, just if your GraphQL happens to have petabytes of data, is it still fast to search for documents or to insert new documents into your GraphQL? Or is it a little bit slower because there's so much data in it?
Well, that's the nice thing about GraphQL. There's no data in GraphQL. It's just a query language for APIs. So how you connect your resolvers or how you choose a library or framework to get your data into GraphQL is determining whether it's slow or not. But GraphQL on its own, if implemented correctly, is a fast protocol. And it's just going over, so most libraries and frameworks, they implement GraphQL over HTTP spec, meaning that you have all the same benefits that you would have in HTTP as well. Okay, well, thanks a lot. And if you have any follow-up questions, me and Sam will be at the conference today and tomorrow. So I hope you enjoyed it, and I hope to see you at a different session. Thank you.